In completing net ionic equations, the first thing you need to do is a double replacement reaction. Now, on purpose, I have these colors. And so what we're going to find is that barium and potassium, the red ones, are going to swap places. So when I move to the other side, I'm going to put potassium, and he's going to bond with chlorine. And notice I'm not writing the subscript because that subscript on chlorine, the 2, actually came from barium. Well, chlorine's no longer with barium. Now it's bonded with potassium. But I do the same thing, and now I'm going to put barium over here with phosphate. So after I've switched to the first 2 positions, then I'm going to recalculate their charges to make sure that they're good. So I look up potassium, and he's in group 1, he's a +1. And I look up chlorine, and he's in group 17, so he's a -1. And so a +1 and a -1 cancel out. Barium is in group 2, so that is a +2. And phosphate is, if we look on the polyatomic iron chart, is a -3. And so because +2 and -3 don't equal 0, I need to balance the charges. And so what's going to happen is this barium is going to get a 3, which is going to be a +6, and this 2 is going to go down here to make a 3 times 2 a -6. And so now those balance out. So after we've done that, our next step is to balance. And so kind of going through our steps is that one is that I switch the metals in the reaction. So I'm just going to kind of make a list of things that we're doing. Then 2, I balance the charges on the new compounds. And then 3, it's kind of like just this little checklist, I balance the equation. Usually double replacement reactions are not really hard to balance. So I take a look and I see that I have 1 barium, but I have 3 bariums, so I know I'm going to need to put a 3 in front. And now I have 3 times 2, I have 6 chlorines, and over here I only have 1 chlorine, so I'm going to put a 6 in front. I have 3 potassiums, but I have 6 times 1, so I have 6 potassiums, so I'm going to put a 2 in front. And that does balance. Now I have 2 phosphates, and I have 2 phosphates. So now I'm balanced. So my equation's balanced. So I did step 3. So now step 4 is I need to label states of matter. To do that, I know that what I have to start with are both solutions, AQs. And normally on the other side, I'm going to end up with either solutions or I'm going to have a precipitate, which is a solid. Well, I have to refer to my solubility rules. And what we know about our solubility rules, if you look on your solubility rule chart, is that every time you start with a group 1, so I look at potassium, he's in group 1, those will always dissolve in water. So I'm going to put an AQ. And then I look and I go, okay, what about my other solubility rules? Well, if we look up phosphate, phosphates are not normally soluble. When I look at solubility rules, if it's not a group 1 or it's not an ammonium like an NH4, I look at the back of the compound. And so barium is not in group 1, he's not an NH4, so I'm going to look at phosphate. And what I know about phosphates is they're not very soluble, only when they're with group 1 or with an NH4. And so phosphate is not with that, so I know that that's going to actually form a solid. So that's how I figure out my states. And so referring to the solubility rules. And then last I'm going to do, it tells me to write the net ionic. And so the net ionic equation, sometimes I just call it the NIE, is pretty simple in that I'm going to cancel out anything that is in my soluble. And so if it's soluble on both sides, that means it's just floating around. So if I take a look, I'm going to kind of just rewrite this so that I can do some crossouts. I know that I have barium chloride, and that's in an AQ. So I'm going to look over on the other side, and I can see that barium is in my solid, so I can't cancel out the barium, but my chlorine is in an AQ on both sides, so it's going to cancel out. And when I cancel it out, I have to put the charge back up. There's nothing to take the +2 anymore, so I have to give it back. So I'm going to write barium +2. The next step I'm going to do is I'm going to write down the K3PO4. And I'm going to do the same thing. It's an AQ. I'm going to go to the other side and say, okay, in the AQ, oh, there's a K. And we know that group 1s are always AQ. So if they're in an AQ on both sides, that element cancels. But PO4 is in the solid over here, so he has to stay. I give him his charge back. And then I write my solid down, because if you look, I have barium and phosphate. So I have barium and phosphate. So then all I have to do, I'm just going to kind of rewrite this just to make it neater. So I have barium +2 plus phosphate -3, making barium phosphate. And pretty much when you do these, you really are just going to write down your solid and show how you're telling the story of the solid. Barium reacted with phosphate to make barium phosphate. And so I have to balance it though. I have 3 bariums and I have 2 phosphates. And so that's how we write a net ionic equation. And both of these are still in the AQ format. So that's a double replacement with a net ionic equation. The next one we're going to look at is a single replacement. And so in this case, we can see that I notice, again, I color-coded that the guys are the same. So I have zinc and iron are both metals. And so in a single replacement, it's pretty simple. If it's a metal, it will replace the metal. And so zinc's going to come over here, and he is going to replace the iron. So iron is going to pop out and be on his own. So we're just going to write iron by himself. And then zinc is going to come over here and bond with the nitrate. So I want you to notice I'm not taking the 3. That 3 belonged to iron. So nitrate's no longer living with iron, he's living with zinc. So then I have to balance my charges. So basically it's the same. One, we replace our single replacement, and then we balance our charges. And so zinc is +2. If we look on the periodic table, you should have written it in. Nitrate's -1. And so what do? Yes, zinc is going to needs just a 1. We're going to give a 2 over here, so we have a +2 and a -2 now. So my 2 times -1 is -2, +2, so let's cancel out. And then we just have to balance. So I take a look. I have 2 nitrates on one side, but I have 3 on the other. So I'm going to do a 2-3 thing to make it a common denominator of a 6. So I'm going to have 2 FeNO3 I'm going to have 3 zinc nitrates. And so then I need, since I have a 3 in front of the zinc and a 2 in front of the Fe, and then I'm all balanced. And then the last question said, tell whether the reaction goes. Well, the deal is that the way a reaction goes is that you have to look and see who's more active. And so you have to go find your 2 metals. And so here's zinc. And now I have to find iron. And here's iron. And so what I see is, long as the zinc has a higher activity, the single guy has to flow downhill to knock out what I consider the married guy, the guy in compound. And so since zinc is higher, since the single guy is higher on the activity series, the reaction will go. That's what we say. It will go, or it will proceed as written. If it was the other way around, so if I had started with iron and I was going to zinc, it's not natural for it to climb uphill. Have you ever been skiing and you've lost your ski and you have to go climb uphill to go get it? It's not natural. Natural to go downhill. So zinc will travel downhill and knock out iron, but iron will not travel uphill and knock out zinc. So it will proceed in this direction.